Okay, for this next uh, analysis, I'm going to give you a chance to see where you would fit into the data. I collected this actual data on a group of students who were in a former stats class, but if you want to, go ahead and do this. So get out a piece of paper, find the pulse somewhere on your body and measure it for 30 seconds. Double this and write it down. If you prefer, just measure it for a minute. That would also be fine. Pause the video, and when you're ready, continue. So here's a interesting question, I think. Can people voluntarily lower their pulse rate simply by thinking about peaceful thoughts? I was actually in northern India in the mountains at this meditation center, and I met this guy who he was actually a monk, and he told me that it was common knowledge that the monks in that area could change their pulse rate, could slow or speed up their pulse rate down to even 30 beats per minute or much higher if they wanted to, and they could even bring the blood flow to a particular area of the body. All these kinds of claims, and I don't know if how true they were or not. There have been some interesting studies on meditation and our ability to control parts of our body in ways that we're just realizing might be possible. But let's see what happens in our case. So you've already gotten a baseline pulse rate, how you're feeling right now. What I want you to do now is think about something. Don't measure your pulse right now. Just think about something that makes you very calm and at peace. Memory of the past, maybe a memory from yesterday, maybe from your childhood, maybe something from a movie you saw, or maybe it's just a fantasy image of something that you think would be peaceful. But just close your eyes, pause this video, close your eyes for a couple minutes and think about this. Okay, now go ahead again, measure your pulse, pause the video, and when you're done taking your pulse, subtract the two, your earlier pulse rate minus your current pulse rate. So whatever that difference is the reduction in your pulse. If you did have a pulse of 80 and the second time around you had a pulse of 70, 80 minus 70 would give you a 10, a reduction in pulse of 10 beats per minute. If your number is negative, that clearly means that your pulse went up. So I did this. This was a group of traditional college students in a recent stats class. Here you can see the data. And here, if I take the original pulse minus after that little calming experiment, this is the amount of the pulse decrease. Here's an example of someone whose pulse actually increased after that relaxing meditation. Interestingly enough, this person said they started thinking about the beach and they got so excited that they think their pulse rate might have gone up. Who knows? The question I want to look at here is, does relaxing thought lower pulse rate? Notice that word lower is a little bit different than the research question I had asked. This is actually unrelated to the paired t-test, but I wanted to give you an example of a one-tailed test. So instead of saying, does relaxing thought have an impact on pulse rate or make some kind of difference in pulse rate that could be either higher or lower, it could go either direction. I wanted to give you an example where we specify the direction. Does relaxing thought lower the pulse rate? And because we have that directional word in there, this is a one-tailed test. The null hypothesis mean, notice we could look at, we do in a sense have two groups of data, right? We have all these original pulse rates and all these after meditation pulse rates. And it would be legitimate to conduct an unpaired t-test like we had done previously and see if there's a difference in the average data here minus the average data here. What happens is there's enough personal variation with our unique personal pulses, our thoughts, our current conditions, that if we do that, if we look for a difference between these average pulse rates and these average ones, it's very possible that it gets too noisy with all the variation that we wouldn't be able to see a significant difference, even if it really did exist. In other words, our test wouldn't have very much power. But instead of looking at it as two groups of data, here's where a paired t-test comes in. We subtract these two numbers to get a pulse decrease, and you can kind of think where yours would fit into this whole scheme of what the college students was. We get this pulse decrease that just gives us a single set of data that we analyze. So moving forth in this output, I'm not paying attention to these two sets of data at all. The only thing I'm analyzing is this single set of data. And for that reason, my null hypothesis only has one mean in it. My sample size only has one number here. My sample mean only has one number here. It's because all of these things are referring just to this column, just to the amount of decrease, which kind of tucks in, each one of these numbers tucks in two pieces of data together, but it subtracts out that person's individual variation, which is a really good thing for being able to detect a difference. That's why we would do a paired t-test. It gives us more power, more ability to see a significant difference if there actually is one. So here my null hypothesis is that the mean is 0. What does that mean? Well, if this meditation doesn't actually lower pulse rate at all, we would expect that the average pulse decrease would be 0. There would be some people whose pulse goes up, some people whose pulse goes down. On average, we would expect that to be 0 if the relaxation had no impact on pulse whatsoever. The alternative would be that we have something greater than 0. Why greater than 0? Well, if we have positive numbers here, that means that the pulse was decreased. For example, here's a positive number because this student's pulse was decreased by 18 beats per minute, right? So if relaxing thought actually does lower pulse rate, if that null hypothesis gets rejected, what we're going to say then is that the average is actually greater than 0, that there is some kind of average decrease in pulse that we're observing. Sample size here is 24. This is worth noting. There were 24 students, so there were actually 48 pulse rates measured, 24 originals, 24 after. They're not all shown here. They continue down in my spreadsheet. But remember that I'm boiling each pair of data using this paired t-test method, each pair of data into a single number, and there's only 24 of these single numbers. That's why that number is 24. Sample mean, what is this? Well, the average of these 24 students, the average decrease in pulse rate was a little over 6 beats per minute. So we did see a decrease among the sample of 24 students. Does this give convincing evidence that in the population as a whole we would see a reduction in pulse rate through relaxing thought? We don't know yet. That's what we have to go down here and check the statistics on. So let's start with the p-value here. 0.002. Remember, the lower the p-value, the more evidence against the null, with 0.05 being our typical threshold. We are indeed below 0.05, which tells us we do have statistical significance. It tells us we reject the null, and we conclude that yes, relaxing thought probably does have the potential to lower pulse rate in the overall population at least. however comfortable we feel that these college students are representative of something. So maybe we feel very comfortable this is representative of college students at EMU. We'd probably want to do this on a wider type of sample before we conclude that relaxing thought does lower pulse rate in the overall population. That's statistical significance, but remember, a big sample size can buy statistical significance. In this case, we didn't have a large sample size, but we still don't want to settle just on statistical significance. We want to look at practical significance, clinical significance, effect size. So if we calculate the Cohen's d, again, don't worry about how to calculate this. Worry more about that you should have something beyond the p-value to look at. In this case, Cohen's d 0.5 is that medium effect size, 0.8 is large. So we have medium to large effect size, something worth noting here. Confidence interval is between, let's say, 2.7 and 9.5. What does that mean? It means that, yeah, for our sample, the average pulse decrease in this little study was 6 beats per minute. If we were going to conduct this among EMU college students in general, we would be fairly confident that the average reduction in pulse would be somewhere between 2.7 beats per minute and 9.5 beats per minute. Notice that even in the worst case scenario, we're seeing some reduction in pulse. Notice that 0, the situation where there's no reduction in pulse, is not even in that interval. It's not between those two numbers. So even in the worst case scenario, we're seeing some reduction, and this reduction could be up to as much as 10 beats per minute simply by a couple minutes of relaxing thought. Now, of course, it's possible they were stressed out because they were in stats class. I don't think. We have a lot of fun in stats class. There's all types of things that we could get more detailed or more accurate in our research design. Here, my concern is more about how to interpret the results. Clinical significance would also want to look at, say 10 beats per minute lower isn't even significant in a clinical setting, then even though we do have a medium to large effect size, that isn't going to mean much if even best case scenario, 10 beats per minute reduction isn't important in a clinical setting.